Hello everyone, welcome to my channel Progressive Physics Learning. This video is based on electric field, field lines and field due to point charges, null points and some of good examples we'll discuss in this video. This is a part of class 12 chapter called electric charges and fields. So electric field, we can define electric field like this. Coulomb force acting per unit test charge. Unit test charge. So we'll represent generally with E, that is force per unit test charge, and its units are Newton per Coulomb or volt per meter, and its dimensional formula will be Newton dimensional formula ml t power of minus 2 by Coulomb it is ampere into time, so that this will be equal to m l t power of minus 3 a power of minus 1. This is corresponding dimensional formula for electric field. The direction of electric field we can explain with the help of electric field lines. Electric field lines. Imaginary lines. Imaginary lines that represents path followed by positive test charge in electric field line or in electric field region. So if we are having a positive charge, if we are having a positive charge like this, for a positive charge, we will get electric field lines as diverging electric field lines. For a negative charge, we will get converging electric field lines. And if we are having a system of positive and negative charges, electric field lines will originate at positive charge and they will terminate at negative charge. And if you are having positive charge, a positive charge and a negative charge or negative charge. So due to like charges as we are having repulsive, so that we'll observe this kind of electric field lines. So electric field lines represent the direction of electric field. So we are having few theoretical points here. Tangent dot to a point on the electric field line gives the direction of electric field. and no two electric field lines will never intersect each other. Two electric field lines will never intersect each other. And electric field lines always form closed loops. Electric field lines always form open loops. That means they will always originate at positive charge and they will terminate at negative charge. And we are having few more points like this. If suppose all the electric field lines are equally spaced, then we'll call that as uniform electric field. And if suppose we are having either converging or diverging field lines, then we'll call that as non-uniform electric field. So both are example for non-uniform electric field region. And similarly, if the field lines are closely spaced, so this is also uniform field only. But if they are closely spaced, this is a strong field and this will be weak field. So just look at this. If I consider 2 points A and B, compared to A, B or field lines are very closed. So electric field at B is greater than compared to electric field at A. Suppose if I consider 2 points A and B here in the case of this diverging lines, then electric field at A will be greater than electric field at B. So that like that by observing number of field lines, we can identify whether the field is a strong field or a weak field. So now we'll discuss about electric field due to a point charge. Suppose if a charge q is there, from this charge q at a distance another small test charge is placed and this distance is given as r. Then Coulomb force between them is given as 1 by 4 pi epsilon naught u by r square. So now from the definition of electric field, that is force per unit test charge, it will be 1 by 4 pi epsilon naught q by r square. So this is the expression for electric field due to a point charge and its vector form we can write like this. E bar will be equal to 1 by 4 pi epsilon naught q by r square into r cap, or we can write like this 1 by 4 pi epsilon naught q by r cube into r bar. If this is a positive charge, if q is a positive charge, electric field will be directed away, and if it is a negative charge, electric field will be directed inward. So now if they ask to draw a graph between electric field and distance due to a point charge, you can expect some graph based questions. As electric field is inversely proportional to r square, you will get rectangular hyperbola. So this is about electric field due to a point charge. Now based on this formula, we will discuss one interesting concept called null point. The point at which electric field due to A given system of charges is 0. We'll call that as null point. So first we'll discuss about null point due to like charges. Like charges means charges with same polarity. If suppose we are having two charges, Q1 is a positive charge, Q2 is a positive charge, then this null point will lie along the line joining the two charges. Null point lies along the line joining the two charges, and it is always close to charge of least magnitude. It is always close to charge of least magnitude. Suppose if I assume like this, magnitude of Q1 is less than magnitude of Q2. The separation between the two charges, let it be D, so that null point will be close to charge of least magnitude. Suppose this distance is x, this distance will be D minus x. Now our idea is to find the x value. So at this point, field due to this first charge will be in this direction. Field due to this positive charge, it will be directed away. It will be in this direction. So net field at point P is 0. That implies E1 minus E2 will be equal to 0. Or that implies E1 will be equal to E2. Or E1 is nothing but 1 by 4 pi epsilon naught. I can write K Q1 by x square, that will be equal to k q2 by d minus x whole square, or from this equation I can write d minus x by x will be equal to square root of q2 by q1, or d by x minus 1, d by x minus 1 will be equal to square root of q2 by q1, or from this x will be equal to d by square root of q2 by q1 plus 1. So this is how we have to locate the null point for a given system of charges. Suppose you can expect some examples like this. Just look at this example. If two charges were there, one is having charge q and the other one is having charge 4q. They are separated by a distance d. What is location of null point from the smaller charge? If they ask like this, we have to look at this point. For that, if I assume this distance as x, this distance will be d minus x, so that you can use this formula. X will be equal to d by square root of 4q by q plus 1, or that will be equal to d by 3. So that if this distance is d by 3, obviously this other distance will be 2d by 3. So that is how you can find null point. And similarly, I can give one note point like this. If Q1 and Q2 are having same magnitude, then null point will lie exactly at the midpoint. This is location of null point. So you can expect some questions based on this also. So now I'll give one interesting example. Just look at this example. There are two charges Q and 4Q. Find magnitude of the third charge, magnitude and position of the third charge, position of the third charge, so that total system is in equilibrium. Total system is in equilibrium. For this kind of questions, so if suppose Q is the third charge, I am assuming the third charge as Q. So if it is placed at null point, definitely net force experienced by Q will be zero, so that it will be equilibrium. Now we have to check the equilibrium condition of this other charges also. So between 4Q and Q, I am assuming that force is F1. Definitely it will be repulsive. Between Q and the small q, I'll assume that force as F2. Then only this Q will also be in equilibrium. Already we calculated this equilibrium distance as a d by 3, and this distance is already we assumed that as d, so that if the total system is in equilibrium, then F1 must be equal to F2. F1 is K Q into 4Q by d square is equal to K Q into Q by d by 3 whole square. So KQ gets cancelled. D square gets cancelled. We left with 4Q is equal to 3 square Q, or that will be Q will be equal to 4Q by 9. This is magnitude of the third charge. And as we assumed these two are positive charges, definitely this Q must be negative charge. So with sign, we have to take that as minus 4Q by 9. So this kind of questions you can expect based on null points concept. Now we are having one more example like this. Just look at this example. As we are having, if suppose two identical charges were there, if two identical charges were there, then null point will lie exactly at the midpoint. If suppose a small negative charge is placed at the center, if it is disturbed just along y-axis, I am assuming this total distance as 2r, so that this distance will be r. This distance will also be r. Both the charges will attract this negative charge, and if suppose this is y, then this distance will be square root of r square plus y square. Then that force F due to each charge will be K Q Q by d square. But this force we can resolve into components. If this angle is theta, this angle will also be theta. If this is theta, this angle will also be theta. So that the cos components gets cancelled, will have only sine components. So net force on the charge will be equal to 2Fq sine theta, or that will be equal to 2Fq is K Q by d square. Sine theta is nothing but opposite side by hypotenuse. So we are having 2KQ by d cube. D cube is nothing but r square plus y square whole power of 3 by 2 into y. If y is very small, then net force will be equal to 2KQ by r square whole power of 3 by 2 means r cube into y, and this will be equal to, if I will find acceleration of the charged particle, net force by mass, that will be equal to 2KQ by r cube m r cube into y. If I compare with our general equation of SHM, general equation of SHM, simple harmonic motion, A is equal to omega square y. So that omega will be equal to square root of 2kq by mr cube. So that you can find time period using an equation 2 pi by omega. So, if a negatively charged particle that is placed between two identical charges, if it's slightly disturbed along y-axis, it will execute simple harmonic motion. This is one interesting example. For this, they will ask you time period of oscillation, and for the same model, if suppose you are given like this, there are two positive charges. Definitely null point will lie at the center. A positive charge is placed. So let this distance be r. This distance is also r. And if this positive charge is slightly disturbed along x-axis, so that now from one charge it will be at a distance of r minus x, and from the other charge it will be at a distance of r plus x. So that net force on that will be equal to, both will repel. So that net force on the system in this case will be equal to F1 minus F2. F1 is Q by R minus X whole square minus Q by R plus X whole square, or I can take out Q as common. I'll have R plus X whole square minus R minus X whole square by R square minus X square whole power of 2. Now a plus b whole square minus a minus b whole square will have aq 4ab by r square minus x square whole square. And from this, if x is very small, if x is very small, then that net force will be equal to k q 4 will be there, x by r power of 4, and numerator we are having r, so that it will be 4kq by r cube. So that acceleration will be equal to 4kq by mr cube into x. So if I compare with our general equation of SHM, what is general equation of SHM is A is equal to omega square x for small displacements. So angular frequency will be equal to square root of 4kq by mr cube, or time period will be 2 pi by omega. So this kind of questions you can expect based on this. And then null point due to unlike charges are charges with unlike polarities. That means if one charge is positive, if Q1 is positive, Q2 is negative, in that case, null point always close to charge of least magnitude. Here Q1 I am assuming as having less magnitude compared to Q2. So it is negative charge, it is positive charge. So it will not lie along the line joining the two charges, that is between them. It will just lie along the line but outside and close to charge of least magnitude. So that means here, due to Q1, as it is positive charge, electric field will be directed away. Due to Q2, electric field will be directed inward. If this distance is given as d, if this distance is given as x, net E1 minus E2 will be equal to 0, or E1 will be equal to E2. That implies K Q1 by x square will be equal to k q2 by d plus x whole square, or d plus x by x will be equal to square root of q2 by q1, or from this d by x plus 1 will be equal to square root of q2 by q1, or from this you can find x as d by square root of q2 by q1 minus 1. So if two charges of unlike magnitudes were there, then null point will lie at a point outside the given system of charges, that is close to charge of least magnitude. Here also I can quote one example based on this. Just look at this example. If suppose q1 is q and q2 is minus 4q, you have to identify this point which is at a distance x. Suppose this distance is d. So x will be equal to d by square root of, you should not substitute that minus again, minus sign again, 4q by q minus 1. So that will be d by 2 minus 1. So that will be at a distance of d. This kind of questions you can expect based on this. I hope you enjoyed the video. Please subscribe and share to your friends. Progressive Physics Learning Profile. Have a great time.